Welcome back to our solution. This is a lecture regarding min-max search algorithm. We will try to understand min-max algorithm with the help of this particular example. As you can see, this is a search tree in which the first node, that is a max move. Max mean it is a player which try to maximize its performance, and there is another player which is known as min. It means it always goes for the move which try to minimize the max performance. So if we start the min-max algorithm, we will start from the terminal node, which are the bottom nodes. So in min-max algorithm, max always goes for the move with the highest value. And similarly, min goes for the move with the minimum value, which will minimize the performance of max. So here we are trying to expand or transfer the tree from left to right. At node D, there are basically two childs. One is 2 and the other is 3. As it's max term, max 2 and 3. So what is the maximum value between 2 and 3? That is 3. So it means between these two child nodes at D, if it is max move, so it will go for the 3. So if we move to the right side at node E, there is 5 and 9. As you can see, the max 5 and 9. So the maximum value would be 9. So here the value of the node will be 9. At node F, as its max term, so the maximum value that will be assigned, 1 will be assigned to node F. Similarly to node G, there are two childs, one is 7 and the 5, so max would be selected, that would be 7, so value will be assigned as 7. So if you move to the upper nodes, which are parent node of D and E, that is node B, it is a min node. Min function would be applied. So at node B, the two child have the values of 3, 9. So the minimum value would be selected, which is 3. So it means here the node value would be 3. So it means if it is min term, so min would go to the child D because it has a minimum value for max. Okay. Similarly, at node C, it has two child F and G with the values of 1 and 7. So the minimum value between 1 and 7 would be 1. So here the node value would become 1. So it means if it is min turn at node C, it will always goes for the move with evaluation value as 1. Similarly, if we are done at this level, we'll move to the upper node or the starting node or the initial node. As you can see, it is a max node. So here max function will be applied and two childs of A are B and C. So the values of B and C are 3, 1. The highest value between 3 and 1 will be selected, which is 3. So the value V is equal to 3. So in this way, we have assigned the node values to all of the node and their child nodes, starting from the terminal node till the initial node. Okay. So if we see in terms of examination or entry test point of view, you can see that. So the first question can be asked to find the node values that we have already found. Okay. Next question could be asked, if A is max node, what move it would go for B or C. As we can see, the node value here is 3. So max always goes for the node B. As at B, it is min turn. So min, the value is 3. So it means min always go for the move to the D. Similarly, at node D, it is max turn, so it means max would choose this particular node. So in this way, min-max algorithm is applied onto any of the search tree related to game theory. So it would max would never go if the value of max at node A is 3. It will never go for the node C where the value is equal to 1. So this particular part of the tree would be explored by the min-max algorithm. The optimal paths for max are min. So in this way, there is a major portion of the tree which is not explored. To cope out this particular problem, at this point, the concept of alpha beta pruning would come in handy, which would basically give us to optimize min-max algorithm by pruning all the nodes which are not basically explored or which does not contribute to the solution. Okay, so in the next video we will discuss about alpha beta pruning on this particular tree as well. If you have any question, just try to ask me in the comment section.